Hello everyone, welcome back. So this is the second lecture for the intro to R. Well, last time, remember we did a lot of wonderful things here to create a vector, right? So to learn some very fundamental knowledge about working directories and how to create a new files, how to clean your global environments. So today, what we're going to do, it's basically trying to understand how to use R for some very simple basic mathematical operations. And in this demonstrations here, we are basically using matrix algebra to express this mathematical operation in R instead of using the single number. Well, the reason why we are using a matrix to do it because it helps us to understand how this programming language is being processed in the computer. Especially later when we try to use some functions for statistical analysis, our data, it's never just one number at a time. So we usually have a tables of number. We will have a matrix to actually define different data points, different features, different values in different columns and different rows. So that's why it's actually quite important for us to understand the operations, the mathematical operations in R in terms of matrices. So let's first do some addition and subtractions operations so that you can actually get an idea. Well, before we're doing anything, we can actually try to check what we created last time. And as you can see, we actually have those global environment X and Y defined last time in our previous example. Well, in order to see what they are, again, you can actually type out X and run the codes. It will tell you there are 3 elements in the vector, 2, 7, and 5. And you want to find out what Y is, you can actually run the codes again. Y is a vector with 3 numbers, 4, 5, and 14. 4, 9, and 14. So for simplicity problems, we want to actually add the 2 matrices together. So we want to add X to Y, or maybe Y to X, right? Just additions of the 2. So I can simply basically tell R to do the math for me very simply. So I can basically define X plus Y here. I run the codes, and as you can see, I actually get 3 elements in returns. Well, first of all, let's explain why there are 3 elements. The reason why we have 3 elements in return to our results because we have matrix X, which is a vector of 3 elements, and also matrix Y, which is also elements of 3s. Well, the additions of 2 matrices, it's pretty simple. The first positions of the matrix in X and Y, which is number 2 and 4, will add together to form this new values in the new matrix, which is the value of 6. The second value, the second positions in this matrix will actually add together to form a new values of the new matrix in the second positions. And the third ones, obviously adding the third ones. As you can see, well, this final matrix here that we actually calculate by the additions of X and Y will create 3 values, and each of them are basically an additions of the 2 matrices at the same positions. Well, if you can do additions in this way, obviously you can also do subtractions. So let's see what the subtraction tells us. If we are going to run this line, X minus Y, as you can see, you're actually seeing 2 minus 4, which give you a negative 2. 7 minus 9, which will give you a negative 2. 5 minus 14 will give you a negative 9. So that's basically how you are using the addition and subtraction functions. To be honest, you can simply use the following example to demonstrate, well, R can be simply used as a calculator for you. So for example, you want to calculate values, which is 124 minus 135. You can simply just run these codes and you can still get the answers. So R basically is a very convenient programming language that allows you to use this very fundamental mathematical operations in this programming. But additions and subtractions are easy in matrix form, but multiplications and divisions are not. So let's say I want to actually do multiplications of the two. So I have x times y. So let's see what's going on. So in this case, when we're using two vector to make calculations of multiplications, as you can see, the multiplications here that you see here, it's 8, 63, and 70. Again, it returns 3 elements in returns. Well, now, very important things that you have to note, when we actually creating a vector in R, and we are assuming that R is going to do the multiplication like the usual matrix algebra, it's not actually doing exactly what the matrix algebra do. So in this case, what happened is the R's program is going to take every single values in x and y and trying to multiply them directly to each other. For people who learn matrix algebra, you know that when we're doing a multiplications in matrix algebra, we are basically using the sum of the we're using the multiplications of the rows times the columns, and we are adding them together to actually calculate the multiplications of the two matrices. In this case, well, we are not actually getting what we are expecting, but we are actually getting the multiplication just simply by the positions of the two numbers here in the two vectors. Also for divisions, when you're running a divisions like this, x divided by y, you're also getting only just an individual divisions. 2 divided by 4, you get 0.5. 7 divided by 9, you get 0.7778. And 5 divided by 14, you get 0.3571. So in terms of the calculations, in terms of the mathematical operation here, there might be something that you have to understand of what the R is trying to do, doing for us. So it's not matrix algebra operations that they are doing with these vectors of numbers. Well, you can also use polynomial or power functions like the following. Let's say I want to actually use x to the power of y. So let's see what happened. So when we are trying to use the power form here, we are basically using the x matrix, first element 2, to the power of the first element in the y vectors, and that will give you 16. And the second value here, it's 7 to the power of 9, so you will get a very, very big number. And at last, you have 5 to the power of 14, and even larger. So when you're running this operation here, hopefully it will remind you again, we are not actually doing matrix mathematical operation here. We are basically just doing a regular mathematical operations, even though we are defining a vector in our global environment. Now, I would say, well, as long as you are trying to do this simple operations, right, you can actually pass in any variables, any numbers, right, that to use the same notations, the plus sign, the negative signs, the star, the division signs, and also the power signs for any kind of similar mathematical operations by individual numbers or maybe a vector of numbers. Now, this is more of a computer science topics for people to learn in R, because not a lot of people using R as a productions in the modern day. Most of the time, we are using R as a analytical tools. But if you are going to work in a company in the future and you are trying to pick certain number out of big tables, you might actually want to learn how to find those number or those elements in the tables. So indexing, it's basically how you can call those values from a table, or maybe in generally speaking, a matrix. So for example, we can actually find some values in our global environments X. As you recall, we actually have 3 values in X, 2, 7, and 5. So let's say I want to actually just pick one out of the 3. I just want to call out one element. And I just want to call out the second element in vector X. So what you can do is basically do it by indexing. So you can actually say X square brackets 2. And that will give you the second element in vector X. So let's run it. So as you can see, this will return you with a number of 7, which is the second values in this vector. Well, if you want to call out the second and the third elements in the vector, you can actually use this index syntax. So what you can do is basically define the initial number, the positions in the vector, let's say the second positions, and using a colon to define how far you want to go in this vector. So in this case, you want to go to the third ones. So what it does is it will give you all the elements within vector X from the second positions all the way to the third positions. So let's see what's going on. So I have 2 numbers returned for me in this case, which is 7 and 5. So 7 and 5 is the second positions and the third position in this vector. But what's interesting in R is that you can actually try to drop some element by giving this negative sign in the index. So for example, if you want to actually drop the second element in this vector, so you can run this code X square brackets -2. This negative sign basically means dropping that positions of value. And after dropping this, you see that the returns of the elements will only have the first position value 2 and the third position value 5. One thing very important for you to keep in mind, this indexing, it's basically give you an idea how to call those elements in the vector, but it has nothing to do with the global environment itself. As you can see, global environment X still has the 3 values, 2, 7, and 5 stored in memory. So it's not going to affect the actual global variables. It actually just returns whatever the value that you are calling out right now. And also, at last, you can actually drop the first 2 elements by using even more complex combinations of functions. So in this case, we are basically calling out vector X, and we want to index something inside, and we are basically giving functions here. Negative means, well, dropping. Well, dropping what? Dropping a list from the first to the second. So from 1 to 2. So we are dropping the first position to the second position's number. So in this case, all we should expect to return, it's only the last values in this vector X, which is the value of 5. So those are the simple indexing syntax that you should master on, I would say, because, well, this is the most asked technique that you should learn in the data science industry. So try to practice more on this so that you can actually get used to those syntax. It's very important that you have to use this kind of indexing technique sometime for your debugging too. Well, we are also going to put some time on learning how to create a matrix. So basic matrix in R, it's going to give you an idea on how to create a true matrix, not just a vector, not just a list of numbers. So in this case, let's say we want to create a 3 by 4 matrix and with the sequence from 1 to 12. So keep in mind the dimensions of the matrix in R, it's defined by the number of rows first, which is usually defined by I rows, and then the number of column, and usually defined by J column. So in this case, as you can see from my syntax, I can actually use this function called matrix. And I have a parentheses here, and I'm going to create this matrix with a sequence from 1 to 12. So it will take the value from 1 to 12 inclusive, and it will take 3 rows to fill those numbers and 4 columns to fill those numbers. So let's see what it means. So let me run this, and as you can see, a variables here, now it's being created. It's called Z. So this Z, it's not a values, it's data. The reason is because this Z, it's not a one-dimensional vector. This Z is actually a table. It has two-dimension expansions in a table format. Well, we want to know what's inside the Z. We can basically just ask. Well, now in the output value here, you can see we have 1, 2, 3 rows, and 1, 2, 3, 4 columns. And the numbers will fill in as the following: 1, 2, 3, which is the first column, and then it will go to 4, 5, 6 to the second column, and 7, 8, 9, 10, 11, 12. And as you can see, there are 12 positions, and we just filled all these positions with the sequence from 1 to 12. Again, creating a matrix is not a difficult task, but what's important for you guys to note is that how you can actually call those elements from a table or maybe a matrix. So for instance, if we want to actually get the value from this Z matrix at the positions of second column and second row, we can basically pass in this index syntax. Unlike the vector, in this case, we have to pass in two numbers and separate them by a comma. The first number will define which rows you are going to call out. And the second number is going to define which column you are going to call out. So in this case, we want to find the value in the second row and second column, which by the look of this table, it should be a value of 5. So let's see if that's the case. So it returns with the value of 5, which is what the table suggests here. Let's say if we want to actually drop the first row completely and just see all the other elements except the first row, you can actually still use this negative sign to define something that you want to take out from this output. So you want to take out the first row and have nothing defined for the column. So you're going to keep all the columns here. So let's see what returns. As you can see, well, the first row is disappeared, and all you see from the return output, it's basically the second and the third rows. You can also drop in the second columns, like how you defined earlier, by putting a -2 after the comma. And now you can now see it becomes a 3 by 3 matrix without the original second column. You can also call just a specific columns by maybe dropping some other columns in your tables. So in this case, we're trying to drop comma. This is the columns. We want to drop a list of 2 to 3 columns. So we want to drop second and the third columns in this matrix and just display other columns. So as you can see, now we only have the first column and the last column. You can also check the size of the matrix by using the functions of dim, dimensions. So if you want to know the dimensions of Z, you can simply just run this code and you will get this dimensions here. It's a 3 by 4 matrix. So the first number here refers to the rows. The second number here refers to the dimensions of the column. If you want to know the total length of the matrix, how many elements are inside this matrix, you can also run this code and you will get the length of this matrix, which is 12, because we have a total of 12 values. If you want to list all your variables that you have defined so far in your global environments, because sometimes you want to find out, well, how many variables you have created so far, and you want to retrieve those importance. You can basically use this function called ls, which is list. You can list all the variables in your global environment by just running these functions. As you can see, so far we have defined variable x, y, and z. If you want to remove one of the variables from the global environment, let's say vector x, you do not need to remove everything like we defined earlier. You can simply basically use these functions outm and parameter, trying to put in whatever the variable you are trying to remove from the global environment. By doing that, as you can see, variable x disappears in our global environment. So this is basically the fundamental use of R in terms of mathematical operations and matrices and indexing. Well, in the last lecture of this introductory videos, we are going to use R for some very, very basic statistics operations. So we will come back next time and trying to learn those basic functions used in statistics. So I'll see you next time.